Let's talk about IPH and TAN. So IPH is one of these, it's not new, but it's a new word test that people, I don't think they've got a full grip on how to use it. Right. And that's fair. I don't think the OEMs have really got a full grip on how to use it either. But let's talk through some of the concepts and how to use IPH in conjunction with TAN to get a better picture of the health of our oil and the health of our asset. So, like we said in a review, organic acids and mineral acids. Mineral acids are broken up into strong and weak. And traditionally, in high school at least, we measured all these acids through pH, which was kind of like, how do you want to say? Not, I guess it was related to the strength and the concentration of the acid. But in the oil world, we had to introduce this concept of total acid number because pH doesn't really make a whole lot of sense in an oil-based system. So pH measures acid concentration, total acid number represented the total potential acids that can be produced in an oil. Now, initial pH, which is what IPH stands for, is a test method, which I'm not going to go into here, but it's basically designed to replicate pH, but in oil-based systems, right? So that's why it's called initial pH instead of just pH. Now, what we would expect, therefore, is that as oil hours increase and the oil becomes more acidic, that IPH decreases. Remember, a lower pH number is indicative of a more acidic oil. So what we are seeing is a slow decrease that's probably in line with the TBN number. We also expect there to be a relationship between IPH and oxidation. So as oxidation increases, we're increasing the acid content in the oil, therefore IPH decreases. And in just a similar way as we had with TAN, if you increase the level of hydrolysis as well as contamination, then potentially that relationship gets stronger and stronger. Now, similarly, when we talk about copper and lead, what we're expecting is to see an increase in copper over lead corresponds to a decrease in the IPH. Now, how can we understand the IPH and the total acid number in conjunction with each other? So basically, what we would expect is that as IPH decreases, TAN increases, right? But that's a very, very simplistic form of it. What we need to understand is that just as pH talks about acid concentration and TAN talks about the kind of like the volume of acid, for want of a better word, we can now use these two terms to sort of map out what kinds of acids we have in our oil. So for example, if I have high TAN and I have low IPH, so I'm in the top left-hand corner, that means that I have the presence of both strong and weak acids in my oil. On the top right, so if I have high TAN but also high IPH, that means I have a lot of acids, but the concentration is low, therefore it means I have probably a lot of weak organic acids, right? So probably indicative of just oxidation. If I have low-ish TAN, but low IPH, right? So a low volume of acid, however, they're very strong, that indicates that I have the presence of strong acids. Right? And if I am low TAN but high IPH, that means just low acids in general. So now that can sort of dictate what kind of actions we really need to take and where we should be concentrating our efforts. Because if I have both strong and weak acids, then that suggests that we want to inspect the components and potentially change the oil, right? So the confluence of both strong and weak acids has a lot of potential for acidic corrosion. We don't like that, right? So there's not that much we can do. If we just have weak organic acids, then maybe we just want to monitor, right? Because we have some corrosion potential, but it's not that strong, and we can correlate it with the oxidation, nitration, and sulfation. If we have strong acids only, then we want to monitor the TAN for any rapid increases. Because now, if I have an increase in TAN and it's all strong acids, right? Now I'm starting to move into that top left-hand corner, right? We want to check for oxidation and viscosity as well. And then if we have low acids, then there's no action required. So this map gives us an opportunity to use both IPH and TAN in conjunction with each other. Now, at the moment, none of the OEMs are specifying this. They're just giving hard limits on TAN as well as IPH. But really, the power of using these two together is that it can give us a lot more information than any of the tests on themselves. If you found this content useful, head on over to lubrication.expert. It's a website where there's tons more training courses, they're more structured, and it's available for about $22 a month.